This conference will now be recorded.
Hey everybody, this is Dr. Doug Smith. It is Wednesday at 2:30, so it's time for our Monday through Thursday 2:30 podcast. This is the podcast where you will hear the science about what actually happened in this opioid crisis. Uh, Yesterday we went over some basic stuff. We went over the five studies that showed genetic damage due to exposure to the opioids, due to taking the opioids. All you got to do to get genetic damage is just take the opioids. And the reason that we showed those five studies is because we're Alex and I, and particularly Alex, are undertaking the process of reaching out to as many people as we can, people who've never heard of us, people who've never heard this science, people who've been told opioid addiction, opioid addiction, opioid addiction, and that's all they know. They don't know that there is an alternative explanation that's based on science. And they don't know that opioid addiction is not based on science. It's based on, basically the same process as your horoscope. Okay, it's just the opinion of the psychiatrist. It's all it's based off of. Just like your horoscope is based off of the opinion of the astrologer, the diagnosis of opioid addiction is based off of the opinion of the psychiatrist. And so the image that we showed yesterday is the five articles, and we grouped them together, all five of them, when we did the first citizens petition, so that we would have that image, so that you could see, all five articles, in one glance. Okay, and what you're looking at on the screen today, this is the scientific evidence for not for the genetic damage, but for the dysfunction in the nervous system that occurs, what we call the signature disease, what other people call opioid withdrawal. And if you've ever experienced opioid withdrawal, you know what I'm talking about. You'll never forget it as long as you live. It'll be burned in your memory until either death or Alzheimer's, one or the other. You'll never be able to forget it. Part of the reason you'll never be able to forget it is because of that spike in epinephrine. It just literally burns into your memory. That's part of what epinephrine does. That way, hopefully you don't step on the rattlesnake twice. Hopefully you don't, kick the hornet's nest twice. Hopefully you look both left and right before you head down the trail and run into the bear. That's what epinephrine does, is try to make sure that things that are dangerous don't happen twice. Including withdrawal. That's why people went to such extreme measures to make sure they didn't go back into withdrawal. Okay, going out and buying fentanyl from fentanyl dealers by everyday citizens that's an extreme measure. Why did they do it? Why did you do it? Okay, and part of the reason is you couldn't ignore that voice in your head that said you can't go back into withdrawal. You can't go back into withdrawal. You can't do that again. And part of that voice is epinephrine. Anyway, while we're talking about epinephrine, look at the screen in front of you. Okay, epinephrine is what's also known as adrenaline or catecholamines. If you stay with us long enough, you'll know these terms. And the article there on the left, that's the Dell study. That's the big boy. Okay, that's the Dell study. Okay, it has a very unfortunate title. Okay, the title is descriptive, but wow, is it a lot of words, and wow, is it hard to get through that title. Okay, that title does not need to be that difficult. This is part of what they do with scientific and medical studies. They add a layer of complexity. That title doesn't need to be that difficult. Okay. But look in that title and look for the word catecholamines. Okay, that's adrenaline. Okay, and look for precipitated morphine withdrawal. Okay, so what this study's looking at is adrenaline levels in opioid withdrawal. That's what the study's looking at. Okay, this study is looking at adrenaline levels during opioid withdrawal. Now, specifically, the type of withdrawal that it's using is withdrawal from Narcan, naloxone. Okay, we'll stop and think about it. You're doing a study. This study was actually done with rats. You're doing a study what are you going to do? Sit around and wait for 3 days while the rat goes into withdrawal? Or are you just going to give him a big old, whack him with a big old dose of Narcan and immediately put him into withdrawal? It's a whole lot easier to do the study if you just give him a dose of Narcan, knock him into immediate withdrawal. Okay, if anybody out there has ever been in, has ever gone through an opioid overdose and gotten Narcan, you know that when you came to, you were in withdrawal. Narcan will put you right in withdrawal. That's how it saves lives. Okay, it stops the respiratory depression and puts you in withdrawal. And and these researchers, they use that when they're doing their research. It's just an easier way to do it. Okay, it's a lot easier. Otherwise, you're sitting around waiting for days. And so, what they're doing here is they're taking mice, rats, laboratory rats that are opioid dependent, and they're giving them Narcan, putting them in withdrawal, and they're measuring epinephrine levels, catecholamine levels, adrenaline levels. Okay, and look at the quote there on the bottom. Okay. By the way, SNA is sympathetic nerve activity. Okay. Although renal, that means kidney, kidney, SNA, sympathetic nerve activity, although kidney, renal, sympathetic nerve activity was inhibited by approximately 50%. And here's the moneymaker. Here's the take home. Adrenal sympathetic nerve activity and lumbar sympathetic nerve activity increased by approximately 400% and 800% respectively. Now, let me read that again and tell you why it's important. Okay, the part that's important there is adrenal sympathetic nerve activity increased by 400%. 400%. Okay, if you're walking at a mile an hour, okay, and you increase by 400%, okay, you're moving. Okay, a 400% increase is a massive increase. Okay, and so if you're a nerve, and that's what this is. It's a nerve. Specifically, it's the sympathetic nerve. Now we'll talk about that here. Hang on. Let's not get lost in the science. Okay, so what this is saying is that the little tiny nerve controlling the adrenal gland, when they gave the mouse the Narcan, they put the mouse in withdrawal. The little tiny nerve controlling the adrenal gland went haywire, went crazy, went wild. Okay, that's what this is saying. Now, it's saying it in scientific, mumbo jumbo, but that's what this is saying. The little nerve controlling the adrenal gland went wild. When you went into opioid withdrawal, the nerve controlling your adrenal gland went wild. When you went into opioid withdrawal, the nerve controlling your adrenal gland went wild. Now, why does that matter? Well, that little nerve controls the adrenal gland, which is where adrenaline's stored. Okay, that's why that matters. And the reason that adrenaline is stored in your adrenal gland is because the darn stuff will kill you. Adrenaline is a very powerful molecule. Okay, in fact, adrenaline may well be the most powerful organic molecule in the universe. A little bit goes a long way. Okay, and your body tightly controls adrenaline. It's got a half-life of 2.5 minutes. That means when you get a squirt of adrenaline, okay, you step on a yellow jacket nest, you get a squirt of adrenaline. Okay, unless you get another squirt, 2.5 minutes later, half of that adrenaline's gone. Okay, just enough. It's around just enough to get you off that yellow jacket's nest, get you out of that rattlesnake den, get you away from that lion or bear or tiger or whatever it was. Okay, it's around just long enough to get you moving. Okay, because if it's around too long, it hurts your heart. Okay, so adrenaline is stored in the adrenal gland, very tightly controlled. Okay, it's part of the sympathetic nervous activity, the fight or flight. That's what SNA, sympathetic nerve activity, sympathetic nerve, the sympathetic nervous system. That's the fight or flight system. You got fight or flight, you got rest and digest. Sympathetic nervous system, parasympathetic nervous system. Oh my gosh, we're over time today. You get me started on this and I'll just go on and on and on. I want you to understand the science. Golly, we didn't talk about it. We'll go with this same graphic again tomorrow, everybody. And we didn't even look at the other study. We hadn't gone through the whole Dell study. Okay, the reason I spend so much time on the Dell study is because if you look real close, it was done in 1990, folks. 1990. OxyContin was approved in 1995. The Dell study was published in 1990. Okay, and quite frankly, no opioid on the face of the planet ever should have been approved after the publication of the Dell study, because what the Dell study shows is that opioid withdrawal is actually a major dysfunction in the nervous system. It is a major dysfunction in the body. When you go into withdrawal, it is a major dysfunction in the nervous system in your body. That is a dysfunction in a one of the main organs in your body. You can't approve, the FDA can't approve a drug that causes a dysfunction in a major organ system. Okay, the reason that the FDA exists is so that drugs that cause major dysfunctions in the organ system don't get approved. Now you're looking at the Dell study from 1990, and it's pretty clear. Okay, Dell cut these little mice open and put voltmeters on them and measure the nerves directly. There's no arguing with this. Chang replicated it 3 months later. Okay, so we'll hold here for today. I apologize, we're a little long. You get me started on this and wind me up and get me going. But I want our people to know this. I want our people to be educated. Okay, because our people are not drug addicts. They're not opioid addicts. They never were opioid addicts. Okay, they were genetically damaged by a product that never should have been approved, and that genetic damage results in the dysfunction in the autonomic nervous system. But we're going to hold here for today. Please don't forget to like and subscribe to us. Don't forget to post this podcast on your social media and everybody else's social media. Alex is working night and day to get emails out to everybody. Okay, if you don't get an email from us this week, send us your email address, and we'll double check it. Everybody will be back tomorrow. Enjoy your afternoon. Enjoy your evening. And thank you very much for listening to us. Alex, thank you for everything that you do. Bye-bye, everybody. We'll see you tomorrow.